Welcome to this video on nominal and effective interest rates brought to you by the Answer series. These terms are probably new for you at this point in finance, where up until now we have referred to interest rate. You will see that this has in fact been the nominal interest rate. We will now also introduce the concept of effective interest rates. What we have had up until now are interest rates which have been quoted per annum but compounded more frequently during the year. This is what is known as nominal interest rates. We haven't used this terminology yet because we haven't had to differentiate it from any other. We can write nominal interest rate as I with a subscript NOM. To distinguish between this nominal per annum stated interest rate and the interest rate that comes into effect when compounded several times during a time period, we need to understand the actual effect of compounding interest more frequently during a time period. Looking at calculating interest in this way is referred to as the effective interest rate, and we denote this with I subscript EFF. So what is the connection between the two? If we look at this equation, we have worked with this formula for the compounding factor. The only difference here is we add in this little subscript NOM for nominal interest rate. The outcome of compounding interest this many times during a time period will result in the effect of the interest over the whole time period. Hence, we equate this with the one plus the effective interest rate. If you think about it, nominal and effective interest rates will be the same if interest is calculated only once a year. In other words, if we were to make M 1, you can see you'll land up with 1 plus I subscript EFF equals 1 plus I subscript NOM. The difference between the nominal and the effective interest rates will increase the more times interest is calculated in a single time period. And think for a bit which one will be greater. Given this formula, we are able to convert from one to the other. Let's look now at the concept of these interest rates further using examples. In this worked example, we have been asked to calculate the effective rate. We are working here with 14% per annum, and in A it is compounded quarterly, and in B it is compounded daily. So for A, because it is compounded quarterly, we use the interest rates equation. And on the right-hand side, we take the 14% and divide it by 4 and take it to the power of 4. Then, solving for I subscript EFF, we get an answer of 14.75% per annum. Notice, as shared earlier, this is slightly larger than 14% because it has been compounded 4 times during the year. For B, the 14% is compounded daily. So for this, we use the interest rates equation, and on the right-hand side this time, we divide the 14% by 365 and take it to the power of 365. This time, solving for I subscript EFF, we get an answer of 15.02% per annum. Notice again, as shared earlier, this is even larger, seeing as though it has been compounded 365 times during the year, which means it is going to grow more than when it is only compounded 4 times per year. You may find it interesting to investigate now how much the effective interest rates differ for the different compounding frequencies. So let's also look at the effective interest rates here for half-yearly and monthly using this same nominal interest rate of 14% per annum. Pause the video to give these calculations a try on your own first. The effective interest rate, when compounded half-yearly, and this is also known as biannually or semi-annually, works out to be 14.49%, and when compounded monthly, works out to be 14.93%. These amounts all fit the logic that the effective interest rate just greater than the 14% per annum was when interest was compounded half-yearly. The next was the interest compounded quarterly, then monthly, then daily. For this example, we are asked to calculate the nominal rate. which means we have to use the same equation, but working in the other way. In A, we are given that the effective interest rate is 13% per annum, and we must calculate the nominal rate if the interest rate is compounded monthly. Because it is monthly, we divide here by 12 and take it to the power of 12. Then calculate carefully to solve for the nominal interest rate, and we get our answer of 12.28% per annum compounded monthly. Then in B, we are given that the effective interest rate is 16% per annum, and we must calculate the nominal rate if the interest is compounded semi-annually. We must therefore divide by 2 and take it to the power of 2. Then, again calculating carefully, we get an answer for our nominal interest rate of 15.41% per annum, compounded twice a year. In this example, Sarah has received a bonus. She is given two options for investment. Either she can put it into an account earning an effective interest rate of 9.6%, or into another account earning 9.5% per annum compounded monthly. In part A of this question, we have been asked to work out which is the better option for Sarah. Part B asks you to calculate future values of her investment in each of these cases. Let's start by looking at Part A. What is useful to realize here is that we do not need to work out what the value of the bonus was. Then, to decide which option is better, we can't just compare the 9.6% with the 9.5%, seeing as though one is an effective rate and the other a nominal rate. Have you figured out what you need to do? Pause here and give it a go before we move on. Let's have a look now at the solution. We have the effective interest rate of 9.6% per annum. So let's take the nominal interest rate of 9.5% per annum compounded monthly and work out the effective interest rate for this. This is then the equation here with 9.5% divided by 12 and to the power of 12. And the solution for the effective interest rate is 9.92% per annum. And if we now compare the two effective interest rates, this is a better option to the effective interest rate of 9.6% per annum. You will notice we have saved this compounding factor in the memory of the calculator. This is to save you from having to type it in again when you do part B of the question. A useful technique is to read through your full question before you begin so that you can get a feel of what is coming in the later parts. This can save you time and effort, allowing you to work smart. So if we look now at part B done the smart way, option 1 is the 25,000 Rand bonus. In the bracket here is 1 plus 0.096, which is 1.096 for 5 years, giving us an answer of 39,536. Option 2 is the 25,000 Rand bonus times the value in A, the memory, to the power of 5 for 5 years. If you didn't save the compounding factor into your calculator's memory, then you can just re-enter it here. In this case, the value of her investment is 40,125 Rand and 24 cents. The difference in the investments after 5 years is 589 Rand and 24 cents. It is important to check you've read your question thoroughly so that you don't miss the final steps required, especially after having done all the hard work.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.